This is Unit 3 Triangles, Lesson 3.5, Motion and Congruent Triangles. Please make note both the location that you are watching this video as well as the date and time. Don't forget to get a parent, guardian, teacher, or librarian sign-off. As we take a shot at this problem, there's a couple short typos we need to take care of. I'm going to read, and I'd like you to filter this with me. It says, draw an isosceles triangle with Q as the vertex so that PQ and QR are the legs. So we have an isosceles triangle, Q as the vertex. It says, then draw an altitude, underline the word altitude, from Q to side PR. And then I want to add intersect at T. Intersect at T. The altitude's going to intersect side PR at point T. We're going to draw in an angle bisector for angle QRP. The angle bisector intersects side PQ at point U, so that UR bisects QRP. It says, if the measure of TQR is 60, find the measure of, this should read PUR, the measure of angle PUR. That's what you're ultimately trying to find. So there's two typos there you need to fix. What I'd like you to do now is reread that out loud. Then I'd like you to attempt to do this problem all by yourself. Draw it and solve all by yourself. Do not pause the video. I'm going to set a timer for you for 3 minutes. You need to draw, label, list, cross out, ask yourself what you can do, circle, plug, chug as necessary, but solve ultimately for the measure of angle PUR with the given information. I'm going to set the timer now. Okay, let's take a look and see how you did. First off, we have an isosceles triangle PQR with Q as the vertex. So let's start by drawing that. Q has to be the vertex, so Q goes at the hinge between the two congruent sides. Here's P and R. It doesn't matter which direction is P and R. I'm going to cross this out as we've taken care of it. It says draw an altitude from point Q to side PR intersecting at T. So here's an altitude, corner down to a right angle at point T. Cross that out. Draw an angle bisector of QRP. Here's Q, here's R, here's P, so that's this angle we're going to cut in half. I'm drawing an angle bisector here. Remember, the angle bisector does not necessarily hit the midpoint of the opposite side. Your eyes are focused on the angle, not the side. That's why I like to draw angle bisectors with going through the opposite side. And that angle bisector bisects side P to Q at point U. So this is point U. We're told that the measure of angle TQR is 60. TQR, it starts at T, go to Q, go to R, is 60. And we ultimately want to find the measure of PUR, which is this angle here. Okay, so let's work from there. First off, if this is isosceles, the altitude also bisects the top. So if that's 60, this is 60. And the whole thing, therefore, at the top is going to be 120. These two base angles have to be congruent. Angle P and angle R have to be congruent. You take 120 away from 180, you're going to get 60 divided by 2, and each of these must therefore be 30 degrees, which makes this cut in half is going to be. Alrighty, let's get into today's lesson. We're going to be learning lots of new vocabulary, so please take a moment to read and check each of these vocabulary words. Please read and check each of those vocabulary words. Read them out loud, check them off. Go. We're going to start with the concept of motion in geometry. The concept of motion in geometry. So I'd like you to physically trace this triangle on the left. Trace it. Now I'd like you to draw an arrow as if you're just sliding it to the right. Slide. Now retrace the new triangle. This second triangle is called the image of the first one, which is called the pre-image. This motion of sliding has another name. The technical name for sliding in geometry is called translation. Translation. Now I'd like you to trace this triangle on the left again. Now imagine if this was a cardboard triangle and you were to flip it directly over. So do like a flip motion. Also think of it as a reflective, or if there was a mirror here, if you were to flip it over to the other side like a mirror, this mirrored image is called a reflection. Reflection. So the first sliding motion was translation, the second one was reflection. Now imagine if your finger was right at that dot, if you were to anchor at that corner and then turn the triangle. That turning motion is also called a rotation. So the three motions of geometry, the slide motion is called translation, the flip motion is called reflection, and the turn motion is called rotation. Say it out loud again. Translation, reflection, rotation. I'd like you to take a moment and I'd like you to draw a translation of R, please. Draw a reflection of R, please, and then draw a rotation of R. You do that yourself. I'll wait about a minute. Okay, let's check here. Translation just means to slide it over, so your R technically should look exactly the same. Reflection means a mirrored image, so draw a little squiggle to represent a mirror, and a reflective image looks like this. A rotation image depends on how much you rotate. If you were to rotate this 90 degrees, it would look like that. If you were rotated 180 degrees, it would be flipped upside down. So either of these would be considered a rotation. Now with these motions, I'd like you to turn to page 41, and I'd like you in 1 minute to label 1, 2, 3, 4, 5, 6, translation, rotation, or reflection. Go. Okay, let's see how you did. This first one. This first image is a reflection. Reflection. Of course, this, which would be the flip, if you will. This is a rotation. This is a reflection. This is a translation. This is a little bit harder to see. It is a reflection. And of course, this is a translation. Okay, now with these motions, we're going to talk about congruent triangles. Congruent triangles. I'd like you to take a look at these two triangles here. And I want you, says triangle BST, so I'd like you to trace BCD. Trace it just BCD and RST. I'd like you to ask yourself, what is the motion from left to right? What is the motion going on there? You write in something here, translation, rotation, or reflection. You should have said rotation. If you look very carefully, point D, which corresponds to point T, rotates upward. And as you rotate upward, this single sweep B, which corresponds to R, comes this way. So it's a rotation motion going on there. Now, when triangles go through those motions, the corresponding points are congruent. So angle B is congruent to angle R, the single sweep, angle R. And angle C, double sweep, is congruent to S. And angle D is congruent to angle T. You can see how these correspond right from the letters. B is congruent to R. C is congruent to S. D is congruent to T. These are called corresponding vertices, So technically, all we did was take the first triangle and we moved it. And because we moved it, it's technically the same triangle. So these triangles are completely congruent. Therefore, all the angles are congruent. The corresponding angles are congruent. I'd like you to trace these sides and fill those out yourself. Take about 30 seconds there and fill out those blanks. BC is congruent to what side? CD is congruent to what side? And DB is congruent to what side? Let's see if you're correct. B to C, from single to double, has to be congruent, B to C, to R to S, because R and RS has to be in that order, because B goes with R. So the order here, B to C, is R to S, and only R to S. Next is C to D. C corresponds to S, so we're going from double to triple, so double to triple, that's going to be S to T. That is the only correct order, not TS. And D to B, that goes from triple to single. Triple to single here is T to R. So those are the corresponding angles and the corresponding sides. So note, when you have congruent triangles, there are always 6 items that are congruent. 6 items, 3 sets of angles, and 3 sets of sides that are congruent. Note, you must correspond the congruent vertices. So what I'd like you to do here is, it says you must correspond, what is the motion of the left to the right triangle? So from this left triangle to the right triangle, ask yourself, what is the motion there? Your word there is either translation, rotation, or reflection. You should have written rotation, because if you look at this triple hatch and you swing it around, it matches up here. So it's not a reflection. If this was a reflection, it would look like this. If this was your reflective mirror, your reflection would go straight over like that. So it's not a reflection, and it's definitely not a translation, because translation means it's the exact same position from left to right. So we have a rotation here. So we want to match up what is the triangle congruent to M, L, W. So M, L, W. M, single sweep. The corresponding vertice on the triangle on the right-hand side, in this triangle, on the right-hand side, the single sweep is going to be L. So it's going to be triangle L, and then here, L is the double sweep on the left. I have to look for the double sweep on the right. The double sweep on the right is vertice M. And then W is the triple sweep. 1, 2, 3, and its corresponding on the right-hand side is N. So you have to align your vertices, single to single, double to double, triple to triple sweeps. So triangle MLW, M, single, L, W, single, double, triple, is congruent to L, M, N, single, double, triple. You try this one. Says, in the diagram to the right, technically below, what is the motion of the left triangle to the right triangle? So you fill this out. What is the motion going on there from the left to the right? Then fill this out. Triangle RQE is congruent to which triangle? I'll give you a minute to fill those two out. Okay, let's see how you did. From the left to the right, well here we actually have a mirrored image this time. If you go down the side, you can see the left to right is the same thing, so it's a flip motion. So the first answer, you should have said reflection. And for the second one, R corresponds with the single sweep R on the right-hand side, so it's going to be vertice R. Q, double sweep, corresponds to the double sweep Q on the right, so RQE goes with, and then E corresponds triple hatch with this vertice P. So just to clarify, from left to right, RQE. This is easy if you actually trace it. So RQE, single, double, triple, is congruent to RQP, single, double, triple. And you can see how those vertices align. So what's going on here is when the whole triangles are congruent, all the parts are congruent. Here, the orange triangle and the yellow triangle are exactly the same triangle. They're just reflected. And if all the triangle is congruent, then all three angles are equal, 1, 2, 3, as well as the corresponding sides. So once again, if the whole triangle is congruent, all the parts are congruent. And when we say parts, we mean two things. We mean the angles and the sides. There's a fancy name for this concept. It's CPCTC. We want to write this out. It is corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So if the triangles are congruent, all the parts are congruent. Another way of thinking about this is if your whole hand, if you have congruent hands, then all the parts of the hands, the individual parts, which would be like the fingers, are congruent. So if the whole hands are congruent, the parts are congruent. Now, big question is, how do you get congruency? How do you get things congruent to begin with? Well, first, things can be pre-marked for you, as in here, in this diagram, we had a bunch of things pre-marked with hatch marks and sweeps. Now, there's three sources of congruency that are considered what are called freebies. Freebies is a non-technical term, which means that they're always true, even if they're not marked. They're always true, but they may or may not be marked. So there's three sets of freebies for congruency you should be familiar with. The first and the most common are vertical angles. If you see vertical angles, you should just automatically mark them, those bow ties equal. Another source congruency is if you have two triangles which share a common side. So taking a look here, trace this with me, a triangle on the left and a triangle on the right. You see that they share a common side. That's called a reflexive side. That's congruent to both triangles, so you would literally mark it with a hatch mark between them. That means this side is common to both, it's congruent to both. That's called a reflexive side. You see the word reflexive because it looks like the red is reflected over to the orange anyways. And then you have what's called reflexive angles. So here, this triangle, trace it please, and this triangle, trace it, in this is a common side. That's why it's called a reflexive side. In the red and blue triangle here, they do not have a reflexive side, but they do have what's considered a reflexive angle. They have a common angle, an angle that's shared exactly by both. We would sweep and mark that with a hatch mark. So let's take a look and mark the freebies below. Here, in this freebie, we have a common side. That's a reflexive side. Here we have this triangle, and we have this overlapping triangle congruent, so here would be a reflexive angle, so hatch mark. Reflexive side, reflexive angle, and here would be a pair of vertical angles. So again, those are all congruent, but they may or may not be marked, so you have to be able to spot them. Now this I'd like you to try yourself. I'm going to set the timer for 2 minutes. First answer question number 1, then do question number 2. You have 2 minutes. Go. All right, let's check your answers and see how you did here. First off, we want to talk about the motion from the left to the right, from the left to the right. And to get this motion, to get that there, it's a rotation kind of motion. So your first answer is it's rotation. Then we want to line up K. K is a single sweep. It matches with the single sweep T. And then S. S is a double sweep on the right-hand side. So it matches up with U on the left-hand side. And then I is a triple sweep on the right, and then going to the left, your triple sweep on the left is angle S. So KSI is congruent to triangle TUS, and that rotation this time was from right to left. Let's check here. You're supposed to mark freebies. Mark freebies. I'm going to mark freebies in red here. No, red's already on there. Let's see. Let's do pink, hot pink. First off, your first freebie here is the reflexive side. Reflexive side. Here, your freebie are the vertical angles. You should sweep and mark them. Here, the freebie is, again, another reflexive side. Here, we have a blue triangle and an overlapping green triangle. They share the common angle H, so that means H is a reflexive angle. All of those are congruent, even if they're not marked congruent. That's why they're called freebies. Make sure you can spot these. It's very important.